Good morning, boys and girls. You will learn elements in group 17 today. This is the position of group 17 elements in a periodic table. The members in group 17 elements are fluorine, chlorine, bromine, iodine, astatine, and tennessine. And group 17 elements are also known as halogen. Halogen is the specific name given to the group 17 elements. So we can call fluorine, chlorine, bromine, iodine, astatine, and tennessine as halogen. And all halogen exist as diatomic molecule in the atmosphere in nature. Why? What is meant by diatomic molecule? For example, the formula for fluorine element is F. The formula for fluorine molecule is F2. Chlorine is Cl2. The molecule of bromine is Br2. The molecule of iodine is I2. The formula for astatine is At2 and then Ts2. So all these particles, all these halogen exist in the form of diatomic molecule. That means the molecule formed by the combination or combine of two atoms together to form a molecule. So we call it diatomic molecule. Uses of group 17 element in our daily life. The popular bleach that we use, or the most popular bleach in the market, is called Clorox. Clorox is made from chlorine. So chlorine is widely used in bleach. Bromine as a substance in fire extinguisher, and the iodine is a good disinfectant. Changes in the physical properties of elements when going down group 17. Let's study this table. Just now we had learned the first member in the group 17 is fluorine, followed by chlorine, bromine, and iodine. So in this section, we only focus to these three elements, these three halogen, chlorine, bromine, and iodine. Let's look at the melting point. The changes of melting point of from chlorine is negative 101 degrees Celsius. Bromine negative 7, iodine 114 degrees Celsius. So you can see the trend of the changes in melting point as well as boiling point. It increased going down group 17. So we look at the physical state of chlorine. The melting point of chlorine is negative 101, boiling point is negative 34. So room temperature will refer to 25 degrees Celsius. 25 degrees Celsius is above boiling point of chlorines. So at 25 degrees Celsius, at room temperature, chlorine exists as gas. How about bromine? The melting point of bromine is negative 7. Room temperature is 25 degrees Celsius, is somewhere in between the melting point and boiling point of bromines. So at room temperature, bromine exists in the form of liquid. How about iodines? The melting point is 114 degrees Celsius for iodine. It's higher than the room temperature. So iodine exists as solid at room temperature. So from the changes of melting point and physical state, so we can make a conclusion that the melting point and boiling point of group 17 element increases down group 17. How about density? Density of chlorine 0.003, iodine 3.11, 3.12, iodine 4.9. So the density increases down the group. Why the density increase? As you learn in your Form 1 science, density is equal to the mass divided by volume. So the unit assigned to the density is gram per cm cubic. So when moving down the group, you learn in your chapter 2 the number of shells occupied with electron increases, the number of protons, the number of neutrons in the nucleus also increases. So going down the group, the atomic size increase, the molecular size increase. Molecular size increase, and then the relative molecular mass of fluorine, chlorine, bromine, iodine are starting also increases. So that is why the density increase. This is the color of the halogens. Fluorine, pale yellow, chlorine, pale green, reddish brown for bromine, iodine, purplish black, and astatine black. Okay, so why the melting point and boiling point increases down the group 17? Let's go into the detail, the explanation why. When going down the group, the increase in molecular size. The molecular size of chlorine, bromine, iodine increases. Why we refer to molecular size? As I mentioned just now, halogens always exist in the form of diatomic molecules, so it refers to F2, Cl2, and I2. So we are referring to the force of attraction between the particles. The force of attraction between the particle here refer to the molecule. Okay, as you will see here, chlorine is the diatomic molecule, chlorine, bromine, iodine, all these are diatomic molecule. And when going down the group, the increase in the electron shell, that cause the molecular size become bigger. Or you can say bigger atomic size or bigger molecular size, but here we refer to the molecular size. And then increase in the molecular size will cause the attraction force between the molecule become stronger. The force of attraction between the molecule, we call it intermolecular force of attraction. Or the other name is van der Waals force. So the intermolecular force between the molecule becomes stronger. That means we need more heat energy to overcome the intermolecular force of attraction during melting and boiling process. So take example for fluorine. The molecular size of fluorine is the atomic molecule. So two fluorine atoms bonded together to form a diatomic molecule, fluorine molecule. The force of attraction between the molecule, this is the force of attraction between the molecule, we call it intermolecular force of attraction, or we call it van der Waals force. So here are the van der Waals force between the fluorine molecule. This is the van der Waals force of attraction between iodine molecule. So what is the effect of different molecular size to the strength of the van der Waals force of attraction? The bigger the molecular size, the stronger the intermolecular force of attraction. Okay, so if we compare the fluorine and bromine, just look at the molecular size. Iodine has bigger molecular size, so the intermolecular force of attraction between the iodine molecule is stronger than fluorine. So in order to overcome the force of attraction between the iodine molecule, we need to supply more heat energy. So more heat energy is required to overcome the intermolecular force of attraction between the iodine molecule during melting and boiling. Now let's look at this. Group 17 elements have different color. This is the color of fluorine. Fluorine F2, Fluorine is a diatomic molecule. The color of fluorine gas is pale yellow. For information, fluorine is a highly poisonous gas. That is why we don't use fluorine in our school laboratory experiment. And then this is chlorine. Chlorine is yellowish green gas. It's also poisonous gas. So all of the experiments that involve chlorine, bromine, and iodine should be carried out in the fume chamber in the laboratory. And then come the bromines. Bromines, reddish brown liquid. Fluorine and chlorine are gases. Bromine is liquid at room condition. And the iodine give purplish black solid, is a purplish black solid, but the boiling point of iodine is quite low compared to others solid. That is why iodine vaporizes easily when heated. Just using a small heat, you heat up the iodine, it will vaporize, and then you can see the purple color gas released. So that is the purple color gas is the iodine in gaseous state. Thank you for spending your time in watching this video.